We'll go ahead and start. Hopefully we get some people joining us a little bit later, but is anyone on the call new to the user group, the AWS user group?
I'm Barrett.
I've never been here.
All right, Barrett, do you mind introducing yourself?
Name's Barrett Harbor. I've worked on AWS, I don't know, for a while, quite a few years. And my current job, I work at a company called Interfolio, based out of Washington, D.C. It's a HR software services company. And, I just wanted to come meet up with you guys and see what you got going on.
All right, terrific. Well, we appreciate you joining. Was anyone else new?
Yeah.
Hey, Eric.
Hello. My name is Eric Inkapol. I'm from Sweden. I recently migrated to the US 2 months ago. I still work remotely for a Swedish company called World Labs. We are probably going to do the vaccine rollout in the Stockholm region in Sweden. So I came to this talk very interested to learn about how to observe our services and keep everything running smoothly.
All right, terrific. Well, glad to have you here. At this point, I'm going to turn it over to IO Associates, who are helping me run this user group. In addition to Azure, if anyone's interested in learning more about Microsoft Azure, we have those events every month also. And this, Sam and cohorts, it's all you.
Thank you. I think I'll just take the time today just to highlight a few interesting roles we've got at the moment. So whether you're on this call or you're listening back to it, hopefully we get loads of views on YouTube. So Matt's working with a DevOps engineering healthcare startup. They're Tampa based and they're revolutionizing the pharma industry. Everything they do is AWS cloud native and particularly mobile apps. They're looking for mid-level DevOps engineers in AWS, Kubernetes, Terraform, Ansible, and Python. So if anything like that is of interest, then get in touch with Matthew Atkins, who's on the call. Sam's currently working with a software platform team based also in Tampa. They're building and scaling their engineering team. It's an exciting time for them. They're also looking across DevOps and leadership positions. Most importantly for Sam, he's looking to fill a MERN-stack developer role. So it's kind of a mid to senior level position. The main tech focus for that is React to Mongo. They also use Node and Express on the server side. Potentially you could learn those if you haven't done that already. And then finally, if you're into the crypto space, I've got senior lead manager roles across Java, AWS, and JavaScript with React on the front end. All these roles are fully remote, so get in touch with one of us if it's of interest, or feel free to recommend any colleagues or friends that that might be of interest. We've got loads of stuff going on, so we'd love to help some of you find some interesting positions. But yeah, after that, I'll turn you over to Imaya, who's talking about AWS Observability Services. Thank you.
Thank you, Elliot. Hello, everyone. My name is Imaya. I'm a specialist solution architect. I focus on observability at AWS. Just trying to find the share window here. Glad to be here. This is great. I used to live in Tampa. I left Tampa and moved to Atlanta like a couple of years ago. Great place. I still miss Tampa, by the way. And thank you for being here. Really appreciate it. And hope you can see my screen. Can you?
Great. Yeah.
Okay, perfect. Awesome. Okay, so so today we'll be talking about AWS monitoring and observability. I probably should have used observability instead. It probably would have had more audience, I guess, with managed services for Prometheus and Grafana. All right. So there are a few slides, but this is going to be heavily. I'm going to show the console. I'm going to show things in action. So after we get through a few slides in the beginning. So let's set the stage first, and let's look at what observability is, right? So people have different ways defining what observability is and could be and all that. But if you watched Werner Vogel's or Amazon CDO a presentation where or the a keynote where he launched the Amazon managed service for Prometheus and Grafana, along with the AWS distro for OpenTelemetry. This is the specific thing that he called out. He said observability is actually the term that originates in control theory that basically lets us understand the internal states of a system by inferring from its external outputs, right? So imagine you have a complex microservice-based architecture where different services are talking to each other. How do you know which service to go to and which network or which connection to go investigate if someone is complaining about an application or a particular feature in an application being slow? Is that a code issue? Is that a performance issue in the network, or is it like a throttling situation going on there? Is there enough CPU? Is there enough memory? Like it becomes really hard to debug and identify the root cause. So that's where observability comes in. It is a way for you to collect the data from different services and systems in the right manner, and also have the ability to connect all this data together. So when we talk about connecting data, we are specifically talking about connecting logs, metrics, and traces. So unless you connect all these data together, really it's sort of hard to understand what actually is the problem. From metrics, you might be able to get the CPU utilization, memory utilization, and those kind of data. And with the traces, you might be able to see the service latency. So there's no reason to assume a latency situation to automatically be a badly written code, or to associate it automatically to a CPU utilization problem where you don't have enough CPU to process that request. So having the ability to connect all the data together and identify and exactly get an idea of what happened in that moment, that particular request went through in your system, is really critical. So monitoring is basically trying to know whether your system is working or not, whereas observability lets you understand why it isn't working by making that connection possible. So good observability allows you to answer the questions you didn't know that you needed to ask. Like I said, there could be hidden things you might have been totally ignoring a particular part of your system. You may not even have paid attention to that, but you might have been fixing issues in a different way and assuming what could be the issue, but the issue keeps coming back again and again. That is because you probably did not know where to exactly look for and did not know where to go to find the root cause. All right, so let's take an issue timeline, for example. This is the issue start and issue end timeline. And so the initial phase is the detection phase. So that is where you tend to, you basically identify that an issue has actually occurred. So imagine that the issue actually occurs here, but it takes a while for you to even know that an issue has actually occurred. Then basically the measure of that is called MTTT. This is the industry term, which basically determines the mean time to detect an issue in your environment. Okay, then comes the identification phase. So that basically is when at the detection phase is where you get the alarm get triggered, you get the notification, and you start paying attention to things, and then starts the identification phase, and that goes on for a long time, because if you might have monitoring set up, you might have a dashboard to look at, you might even have logs, but how do you, again, going back to correlation, how do you know exactly which particular log group that you need to go to, whom you need to go to look for more details and fix what the issue could be? So that the overall time that it takes to get to the actual root cause of the issue, or the identification of the root cause of the issue, is called MTTI, or mean time to identification, which is again another industry term, which basically measures the mean time that it takes for you to identify the issue. Then comes the fix and verify phases. These phases, we're going to leave them out because that could entirely be dependent on a particular developer who's working on the issue. Someone who's more familiar with the system might be able to roll out a fix quickly. And also it purely depends on, maybe something like your CI/CD pipeline. If you have a strong CI/CD pipeline, that you might be able to roll out an issue really quickly compared to having to do manual deployment. So we'll leave that one out, but the overall time that it takes for you to, from the start of the detection to all the way to rolling out a fix, is called the mean time to resolution. That is also a measure that lots of organizations who are measure all these three different items. So for the sake of this talk, and also when it comes to monitoring and observability, the primary focus area is MTTI. So mean time to identify the root cause of the issue. An issue occurs, you automatically going to this developer saying that, hey, here's this log, here's this data, it looks like this is the problem, here's all this, you could go reproduce this in the environment and fix it. So how long does it take for you to get there from the point of you getting notified about an issue? That's the whole point here. To do all that, AWS has several tools. The AWS Observability in the middle, that is actually CloudWatch and X-Ray that you see here at the top. So those are the two services that actually lay the foundation. They are the ones that have the agents to collect logs, metrics, and even traces using the X-Ray agent. You can collect all of them, send them to CloudWatch and X-Ray, and you have a variety of tools and or otherwise features to make use of the data that you collect. For example, if you look at Container Insights, it is a purpose-built feature that specifically focuses on container workloads. You can easily enable it on EKS and ECS, extremely straightforward. And once you do that, it gives you automatic dashboards, and you can visualize metrics like CPU utilization, memory utilization, network, and so many other metrics based on different levels. It's at the cluster level, namespace level, if you're talking about the EKS terminology, service level, and so on. So it automatically does all that. Not only just that, but it also collects lots of other information from the cluster, like, for example, application logs, collects application logs, performance logs, all that from the cluster. And it also makes you to automatically jump to those log groups and easily query them using the interface. So it makes it a lot easier. And similar things can be said about X-Ray Insights, Lambda Insights, and all that. Even X-Ray Insights, for example, it's a new feature that actually uses anomaly detection to automatically identify faults and traces. So if you have a service that is have an application that has multiple services, and if a particular service is emitting false, like false meaning any 500s, it can it observes over a period of time, and if it finds that and it obviously builds a model over a period of time. If there is any anomaly in those traces, it automatically captures that, creates something called an event or an incident, and then automatically collects the data during that period and sends and highlights that information to you. You can even get notified with it through Amazon Event Bridge or take actions and so on. So there are many such services that are available for you to do all this. You can monitor infrastructure, application, you even use synthetic monitoring using CloudWatch Synthetics by creating something called canaries that can actually go test endpoints like your websites or APIs, or even do simple things like heartbeat monitoring and so on. So I don't want to spend too much time on this slide because the point here is to talk about managed Prometheus and Grafana, but you understand that this is the observability platform, the AWS native observability platform. And you have the instrumentation layer where you have CloudWatch and X-Ray agent that you can use to collect data. You can send them to logs, CloudWatch logs, CloudWatch metrics, and AWS X-Ray. And then you have the insights features that allow you to do more with that data, like query using logs insights and perform X-Ray insights, for example, do more insights into that and all that stuff. And you have CloudWatch Service Lens that kind of gives you the application performance management sort of feature where that helps you connect to all these different things and sets you the context and basically helps you correlate logs, metrics, and traces. So that's the AWS native observability platform solution. Now, let's talk about the open source monitoring options, okay? So in reInvent 2020, like I mentioned, Amazon CTO Werner Vogels, he launched Amazon Managed Service for Prometheus and Managed Service for Grafana. Along with, also he talked about AWS Distro for OpenTelemetry. So Managed Service for Prometheus and Grafana are fully managed services that customers can just start using without having to worry about managing infrastructures and providing storage and worrying about all that. It's just, you get a fully managed environment that you can use, and you pay only for that usage. And we'll dive deep into those two services. Obviously, I'll give a quick overview about AWS Distro for OpenTelemetry, or ADOT, in other words. So ADOT is a downstream version, or I hate to call it a version, basically downstream of AWS, downstream of the OpenTelemetry project. OpenTelemetry is a CNCF project. It is basically an initiative by the open source community to standardize the specifications for logs, metrics, and traces. So what that means is it is a collection of SDKs and also collectors that allow you to define, that allow you to follow a specifically defined standard. So you can, if you use an SDK to, let's say, collect traces in your application, and if tomorrow, and let's say you send it to X-Ray, for example, And tomorrow, if you decided to move to something as, let's say, a partner solution like Datadog or New Relic, you can simply change the collector and the traces automatically go to New Relic or Datadog. You don't have to do any code changes, right? So that is what the OpenTelemetry project is about. And AWS distro is a secure, basically a tested, evaluated version of AWS supported version of OpenTelemetry. It's a downstream project, and any change we make, we actually make to the open source OpenTelemetry project, because we are also in the steering committee. We also actively participate in the design specifications and so on. And we make the change in the upstream, and then we take it to the AWS distro after testing and all that. So those are the new options that customers have starting late last year. Okay, now let's talk about Prometheus. So I don't expect everyone to be an expert in this technology, because this is, if you're not familiar with it, so I just want to make sure that we level set and everybody understands what this is. So we'll talk about Prometheus. I'll even show what Prometheus looks like and show that hands-on, and then we'll jump into the managed Prometheus. So it's easier to understand that way. Okay. Prometheus is a open source monitoring and alerting toolkit. So this is an open source project, and it is also part of CNCF, and it already graduated from CNCF, and it is a lot just like Kubernetes or Envoy proxy or Istio or anything like that. So there are many graduated projects from CNCF, and Prometheus is one of them. And there's lots of action here, simply because Prometheus is really simple to use and at the same time very powerful. So it actually was created at SoundCloud by a few ex-Google engineers, and the PromQL capability is very appealing for customers, because it's quite flexible and at the same time very powerful. And the Prometheus, the format of the Prometheus metric format itself is making it so flexible, so it actually is so suitable for multi-dimensional queries and all that. So it makes it so much easier that way. And also at the same time, there's lots of open source projects, because it's open source project, there's lots of folks contributing to the SDK. For example, there is Java SDK, Go, C#, Python, and you can name a language and probably have an SDK already in Prometheus. So it makes it so much easy for adoption. And at the same time, it has 150 plus exporters. So exporters are basically agents that you can deploy on an environment, and they basically expose an endpoint where that sends metrics in Prometheus format, and you can basically scrape metrics out of that. So there's lots of exporters. So many workloads have exporters, and even many workloads natively export metrics in Prometheus format, like Kubernetes, like Spark from 3.0 onwards and so on. So Nginx, for example, you can run a sidecar, Nginx sidecar, to run a Prometheus metric. So there's excellent adoption from the open source community, which makes it much more appealing for customers. We definitely talked about some of the main features. One, obviously, talked about PromQL and the multidimensional capability. To highlight some of the concepts here, Prometheus works on pull model over HTTP. So what that means is, unlike typical mechanisms where you have an application, if you have a monitoring system, you typically are expected to use the monitoring system's APIs to send metrics. The Prometheus kind of clearly identifies roles or kind of clearly separate concerns as to who needs to do what. If you want to collect metrics in Prometheus format, all you have to do is you use the Prometheus SDK, you instrument your code, and you expose an endpoint from which you expose metrics in Prometheus format. And you have an agent or a collector, in other words, that would scrape metrics from that endpoint. That is typical. That's a typical model how Prometheus works. And in cases where that is not possible, there's something called push gateway, which is basically an intermediary gateway, where you can actually use that to push the metrics to, and then from there, Prometheus will pick the metrics from that endpoint and scrape that. So Prometheus also has a very good service discovery mechanism. It can use the Kubernetes service discovery APIs and discover the resources in your Kubernetes cluster. So it's very popular in the Kubernetes world already. And it can also use static configuration through file-based service discoveries. That is also possible. And Grafana, along with Prometheus, is very popular. Almost 99% of the customers that I talk to always use Grafana along with Prometheus. And Grafana has native integration with Prometheus, and it's very powerful to query from Grafana, and you can create amazing visualizations. Okay, let's see Prometheus in action. Okay, so here I have my Cloud9 instance. Hope you all can still see my Cloud9 instance. Okay, what I'm going to do is let me know if I'm talking too fast, or if you want me to slow down or anything like that. I can always do that. I tend to talk too fast because I get excited, but feel free to interrupt me and ask me if you have any questions. Make it interactive. I love that. Okay, so what I'm going to do is I'm actually going to run my Prometheus server using a Docker from a Docker container. So that's what I did. I basically pulled my Prometheus container, and I'm exposing that through port 8080. What that means is I can actually see that in my Cloud9. So I'm going to do a preview. There you go. And let me pop this out. So that is my Prometheus interface. Okay. So what has actually happened here is that let me show the configuration. So I deployed my Prometheus. This is my Prometheus configuration file. That is default. I haven't done anything. This is just the public Prometheus deployment. What this says is it has a job called Prometheus, but this is all default. And what it says is it's going to scrape from this target localhost on port 1990, which is what it is actually running on. And this is the metrics path from which it is going to scrape the metrics from. Okay, it's very straightforward. Every 15 seconds, it is going to scrape metrics from this endpoint from this target. Okay, it's very straightforward. So basically, what it has actually done right now is we simply deployed Prometheus. And we know that we found that it's actually monitoring itself. So that is what we did. Okay, Prometheus. So that's what happened just now, right? Okay, I'm here. Okay, so now I talked about exporters. Exporters are like small agents and sidecars that you can actually run along with many other workloads to expose metrics from that area. So one of those really basic exporters that is super easy to demonstrate and easy to understand is a NodeExporter. NodeExporter is a little utility, if you may. What it does is you can run it on as a Linux machine, and it would get metrics from the Linux machine, and it would expose in Prometheus format. So let me go to that, and you can see that I have NodeExporter here. So this is you can download it. This is a free open source utility. And I just ran that, and it is actually exposing an endpoint on this port 9100, and it is sending metrics. So if you want to look at whether it is actually sending metrics, I can always go to HTTP. I have to do the, I have to get the port. The IP address. Let me see if I have the IP address. Okay, I can always check that using the IP address. So .17.0.0.1 on 9100 at the metrics endpoint. So I did a curl, and then you can see that it is I am able to see the metrics from that application or NodeExporter. Sorry. So what I'm going to do next is I'm going to change this configuration. It's the same thing. So change the Prometheus configuration here, so it can actually add my NodeExporter also as another target to itself. So to do that, I'm going to stop this, and I actually have a file, a YAML file. So you can see that what I'm going to do is I'm going to just add this target to my Prometheus configuration. Okay, so the way I would do that is I'm just going to run the Docker container again, but this time I'm going to just change the environment variable inside the container to basically merge it with my local one. So I'm mounting my file to my Docker container. Okay, that's what I did. And now if I go to my Prometheus server and just refresh it, if I go to the configuration page, I should be able to see that there. So I'm seeing it. So what this means is now it has just added another target for itself to scrape metrics from. So now if I go and see node metrics, I can see those metrics. So there you go. So these are all node metrics, right? So you can see that they all, maybe it's too big. They're all showing up here. We just started scraping and all that. So I have another server where I have more metrics. So maybe we can use that for easier demonstration. I'll close this also. Let me go to Docker, preview, run application. There's more data here because I started a little bit early. So if I show you a demo so you can understand it better. Okay. Here, we looked at that, and with Prometheus, I mentioned about PromQL. This is PromQL. So what I'm doing is I'm actually executing PromQL. So here, that is bad. Oh, it looks like my NodeExporter is not running on this, which is, or maybe I didn't deploy I didn't redeploy it. Sorry about that. Run that again. It might.
Is that using like the local Kubernetes, or is it just you're just running Docker with Prometheus?
I'm just running this directly on a Docker container. That's pretty much it. I'm not doing anything other than that. No Kubernetes whatsoever. So unfortunately, I failed to reinstall it with the application, but with the NodeExporter included. But that doesn't matter. So I can still show you other metric types. So here you can see that this is PromQL, for example. So what I can do is it's super easy, for example, to filter. Can do this. This is basically filtering, me asking Prometheus to just show metrics from that. If I do the whole thing, I'll only see just one, for example. This is how you filter. So you basically have to run that query, and you get it. This is called instant vector, which you can actually visualize and all that. There are different types of metrics. There are 4 different types of metrics. The basic one is the counter metric, which is basically the ones that keep increasing. Like, for example, if you want to count the number of users logging into your website, that's not going to go down. The total number of count is only going to go up. And the site visits, for example, or you want to count the number of products purchased, or maybe the searches performed on your website, those kind of things, those could be counters that you would use a counter metric type. There's another metric type called a gauge. And that actually is something that you would use to count, to look at CPU utilization and stuff like that. This can go up and down. It doesn't go up and down now because we don't have enough data. If you leave it enough, for long enough, you will understand that it can go up and down. So gauges are those kind of things, those kind of metrics that can go up and down. And there's another one we sort of saw that it's called histogram. It's a little bit more complicated metric. So you can see that this is actually a metric. You can see that this key value pair is unique. So this is one entire histogram metric. There are different buckets here: 0, 0.25, 0.5, 0.75, and 1. So what that actually means is if the go duration seconds, if it takes more than 0.25 seconds and it's less than 0.5 seconds, it will go into the 0.25, the 0.5 bucket, and it's basically a counter. It will just keep adding for one. So it basically is used to count the frequency of things that happen in buckets. So this would something like response duration, and just like what we are seeing here, and also maybe something like total number of bytes received from a response. Though those kind of things are suitable for this. So you can actually use this metric type to kind of understand at what bucket is filling up, and how your response itself is working in your application, and so on. It also is very helpful to find averages. So if you can see that this is the average duration that it takes, you can the histogram is quite useful for that. And you can also use this special function called histogram quantile. Let me see if this is still working. Yeah, this is a quantile function. This actually helps you find the 90 percentiles. Here I'm looking at the 95th percentile of this particular metric, and that's the value that I got, and this is how it looks like. So it's very powerful, it's very fast. You can make use of it very easily as soon as you understand all the different functions that you can use. There are rate function, sum function. There are many functions that Prometheus offers. Makes it so much easy for you to operate on a wide set of data. Okay. All right. So I mentioned about push gateway, right? So push gateway is something that you would use in short-lived jobs that in jobs that cannot be scraped metrics from. If you have, like, let's say a Lambda function, for example, it pops up, runs for 5 seconds. How do you time your Prometheus server to scrape metrics? So what if this one is, even in this case, this is configured to scrape every 15 seconds. So what about those Lambda functions that ran for 5 seconds? Between those scrape intervals, right? So you would miss those metrics. So those were the use cases where push gateway comes in, but push gateway is highly discouraged to use, but it does exist. So you can set up something called a push gateway and push metrics to it and have the Prometheus server scrape metrics out of. So the way you would do that is to demonstrate that. Maybe you can use this one. So let me stop this and let me run another Docker container. And you can see that I'm actually running the push gateway. And this is port 8080. So what I can do is, let me close this. If I preview now, I'm actually looking at push gateway, right? So if I go to this NodeExporter, I don't need NodeExporter for this demo. I actually have a small command that pushes a metric to push gateway, right? So here, all I'm doing is I'm pushing this metric called meetup metric with 3.14, the value of pi to this endpoint, which happens to be my local push gateway endpoint. I push it, so go refresh, and I see my metric here. So that's the value that's a Prometheus metric that I just pushed, right? So from here, I can obviously scrape the metrics out of here and ingest into Prometheus, all right? So that's how it works. Okay, so that is all great, but what happens is when you, this is the architecture that Prometheus has. And what we did just now is we deployed the Prometheus server. We deployed a job, which is the NodeExporter, and we configured Prometheus to pull metrics out of that. We saw that, we queried and all that through Prometheus Web UI. We did all that. And then we also deployed push gateway, and we pushed metric to push gateway through, just command line. You can call it a short-lived job. And we didn't pull metrics from there, but you get the point. You can pull metrics from push gateway, all right? It also has a few other components. We talked about service discovery a little bit. It can discover targets using Kubernetes APIs. Like I said, you can also use file-based service discovery. You can basically just have a file and you mention that, hey, Prometheus, go read this file to look for where you need to go scrape from, and then it will automatically do that. And what you can do is you can continuously keep updating the file if your targets are changing manually with another job. So then you also have something called Alert Manager. So Prometheus has a really strong alerting capability. So what that means is if I go here, I hope this is still running. Okay, not running. Hope this one is running. Okay, that's bad. I think I killed those things. So what we can do here is, because this one is still running, I can preview here. If you go to configuration, you can see that there's something called Alert Manager here. So you can actually set alerting rules. So those rules are can be pretty complex. They basically is like creating CloudWatch alarms. You will set up saying, if this metric crosses the threshold over this many times over this period of time, basically then trigger me an alert. So what happens is you set it up, and Prometheus, it is in the Prometheus server, and then it starts pushing alerts to Alert Manager. And the Alert Manager is the one that's responsible to push metrics to, push alerts to different destinations. It could be PagerDuty, it could be other destinations and so on. So as you can see, Prometheus is pretty, the concerns are well separated. Prometheus server doesn't care whether Alert Manager exists or not. We didn't even deploy it, but it still worked, right? Same goes with Push Gateway. Push Gateway didn't care whether Prometheus server existed. Prometheus server didn't care Push Gateway existed and all that. So it's really well designed in that manner. Its concerns are clearly separated, like I said, and it works very well that way. So that's one of those reasons why customers love it. And also, it can get a bit complex. So what happens is you see this area where you have to provide storage. It starts with that. So because of this ease of you being able to get metrics from different workloads, different environments, what happens is today we have lots of high cardinality environments where we were able to collect lots of metrics. So in those environments, it is very common when I talk to customers in large use cases. Some customers run thousands of nodes in EKS, for example, and they have several thousands of pods because they want to densify and make use of the node as much as possible, right? So in those cases, there could be millions of metrics from that workload, from that cluster, one single cluster alone. So that becomes that throws a lot of problems for customers, because you as a person who's operating this environment, you have to provision Prometheus server with a capacity that it can actually go scrape metrics from all those different endpoints, and also at the same time have the capacity to store all those metrics. Not just that, also have the capacity to be able to respond to PromQL queries, because what's the point in storing all the metrics if you're not able to respond to queries, right? So this alone just introduces lots of complexity, and engineers spend a lot of time optimizing memory and compression and lots of things, and it's repeated it's work that takes your precious time away from you having to spend those otherwise spending that time in managing your actual business workload and so on. So this is an unnecessary overhead that customers go through, and this is a common problem in using Prometheus. It's a great solution, but there is this complexity. And these two open source solutions came to be. So Cortex and Thanos are those open source solutions. They provide an extensive architecture to an options. There come lots of options when implementing the architecture as well, but you have a really good solution there to create a really strong Prometheus backend. So what you can do is you can actually create a highly available Prometheus environment, and that is also scalable using Cortex or Thanos. These are open source projects. These are also part of CNCF, and both offer the same solution. What that means is a Prometheus backend, right? That allows you to create an appropriate storage mechanism, a scalable API environment, a querying environment, a compression and ingestion mechanism, and all that stuff. However, I've talked to so many customers ever since we launched this product, maybe more than 100. There are many who already run Cortex and Thanos, right? But the problems don't really go away entirely. It does. Don't get me wrong, Cortex and Thanos do solve a lot of problems, but they also introduce new sets of problems. Now you're, instead of directly managing Prometheus, you're now managing slightly different type of environment and the systems that you need to solve. If you look at it, it's very similar to Kubernetes. Kubernetes, okay, it came because you have a really strong API that comes with Kubernetes. All you have to do is you have to just create Kubernetes configuration files, and the APIs take care of it. You have strong API that you can invoke through CLI. Everything can be automated, perfect. But that came with complexity that you have to maintain your control plane properly. Although there are APIs, but still you have to provide the network, you provide the storage, provide the compute and all that. So similar problems, if you could relate that problem to this, it would be much easier to understand. So what we did is we picked Cortex among these two. And we have been actively working with the Cortex open source project. In fact, Tom Wilkie is actually the Cortex founder. He's the CTO of Grafana. And along with him, we actually wrote a blog. We recently published a blog about how we've been contributing the Cortex project and all those different improvements we made in the Cortex project to make it work more efficiently with the block storage, for example. Cortex has 100% PromQL compatibility. What that means is if you're already a Prometheus user, you don't have to change anything. You just bring your Prometheus environment, run the same PromQL queries. Everything works perfectly exactly the same. And it is a multi-tenant architecture, which is highly necessary if you want to provide an environment that is cost efficient and also at the same time is able to host multiple tenants at the same time, let's say customers, in other words. It scales very well, and also there's lots of querying, lots of cache layers that allows the queries to be responded very quickly. It also, there are many options for long-term storage. One of those is Amazon S3. We use S3 in our solution as well. So that is where Amazon Managed Service or Prometheus comes in. So using Cortex, we built this, and it's a fully managed, compatible, Prometheus compatible solution that you can ingest, store, and query metrics. Okay, customers really don't have to create any environment. There's really nothing for them to even see. All they do is they just create a workspace, and we provision a tenant for them that is automatically deployed across multiple AZs, and it's tightly integrated with the AWS, IAM, and secure at the same time, and all that. There's really no upfront investment that customers need to do. We just pay for the usage, amount of metric they ingest, and so on. That is the managed service for Prometheus. So what they get is actually this rectangle in the middle, right? So they get a box, which is basically the managed Prometheus workspace, and it has an ingester, or ingester, which basically means a mechanism that allows you to send metrics to. In Prometheus, there is a concept called remote write, which basically allows or makes the Prometheus server to send metrics in near real time to a remote destination. That is we provide an endpoint, so you can configure Prometheus servers to send metrics to this endpoint. Also, there is a querying mechanism or an endpoint that you can use to query metrics from. You can either use Grafana that you can use APIs, or you can even use the Amazon Managed Service for Grafana for that. Okay, and for the long-term storage, like I mentioned before, we use Amazon S3. Here in this part is where the collectors are. So we deployed the Prometheus server earlier. So if you are using Amazon Managed Prometheus, you will still be deploying that Prometheus server like I did, but you don't have to provide storage or anything like that, because you're really not storing anything. You're basically remote writing the metrics into the AMP workspace. So your Prometheus server in your local environment, that just becomes like a collection agent. You can use that, or optionally, you can also use AWS distro for open telemetry. That is another option. And there's also the other option, which is the Grafana Cloud Agent, which is also another option which you can use, which Grafana created. And like I said, we have a close working partnership with Grafana, and they actually made the Grafana Cloud Agent work with AMP as well. So there are many options for you to choose from. All right, so all said and done, let's go look at the console, the Prometheus console, and see what you actually will be able to do there. And I can do that as soon as I find my mouse. Okay. All right, so let me close this and this just to avoid confusion. Okay, let's go to the Prometheus console. All right, so here I am in the Amazon Managed Prometheus service for Prometheus console, and it's a public. This is a service in public preview. You can go create a workspace yourself, and we charge for ingestion. We don't charge for storage or querying, but you can start using right away. So let me see, Tampa Meetup. All right, so I'm just giving a name for the workspace. And I don't know what happens to my mouse. Okay, all right, I am going to click on create. So when I click on create, so this is going and provisioning a tenant in the Cortex environment in the background. In a few seconds, you can see that the status will change to active. It just did, and that's it. That is all it took for customers to get a fully available, highly scalable Prometheus backend, right? So there's this Prometheus remote write URL that you see here, which is what you will use to configure to send the metrics to from your Prometheus servers. And also here's the endpoint URL that you can use to query the metrics from. And that's pretty much it, right? So that is all the customers have to do today, and they don't have to manage storage and all those complexities that is showed in that architecture. None of those exist when you use this. All right, so now how do you even make use of this, right? So let's go take a look at that. Let's close this. Let's go here. All right, let's clean this out. Okay, so what I'm going to do is I'm going to actually show one of the workshops that I have. I call this observability workshop. I own this, and feel free to provide me feedback if you're able to use it anytime. So this is a public site where you can go, and it actually, when you deploy the workshop application, it deploys a slightly complex application that is intentionally made complex to prove the observability capabilities of AWS. Here you can see that there is a front end that's deployed on EKS, and there are multiple ECS-based services written using different languages and so on. So the point here is there's a front end that actually exposes metrics in Prometheus format. Okay, so to get that, let me really quickly go to Systems Manager where I have the URL. Give me 1 second and I'll get that. Let's site URL. Okay, I got this. So if I go here, if you go to metrics, you can see that there's lots of metrics. These are all Prometheus metrics. They look very similar to what you saw in the NodeExporter, for example, right? You can see that there are lots of metrics, and this is one Prometheus metric. For example, if you see this metric, there's always Prometheus always tells what type is. This is help. If it starts with hash, it's commented, and so you know that that is not a metric. That basically information about the metric, and that's also help, which you can actually use the Prometheus SDKs to add to any metric that you expose. So the point here is this application is exposing metrics in Prometheus format, and not only it collects lots of metrics from the .NET runtime environment, but also there are custom application metrics that I am collecting as well. So these are custom metrics that I'm sending from my application. Okay, let's keep it aside for now. And let's go back here. So now understand that there is an application that I've deployed in my Kubernetes cluster. I forgot to mention that. You can see there's lots of pods running here. There's a bunch of them running, and my application itself is running here. That's a deployment. That's the application running. And I don't have any Prometheus or anything installed as of now. Okay, so what I'm going to do is I'm going to just go and create a namespace called Prometheus. Okay, so that's Kubernetes. If you're not familiar with Kubernetes, it's not rocket science, but it can be rocket science at certain points. But just bear with me for now. So you can see that I have created a namespace. Namespace is just called Prometheus. Namespace is just a for you to logically group resources in Kubernetes. Let's put it that way. So I have an EKS cluster. I just created a cluster. Sorry, a namespace called Prometheus. And what I have to do is I'm going to go through the workshop. Okay, something's wrong with this mouse or Zoom. I don't know what. Something disappears. Okay, so I'm gonna, if you go to the workshop, you can actually go through this module, for example, and you can actually see that we have specific instructions for you to go through to set up ingestion from EKS. So what I just did I created the namespace called Prometheus, and what I'm going to do is I'm actually going to not do all this because I have these are just instructional. So I'm going to, these are instructional to get the details for this, values for this. I already have them, so I'm going to get I'm going to run that, run those two commands. Basically, I'm going to set the environment variable now. Here, these environment variables, the IAM proxy role and the AWS region. I just set them up. All I need to do is I need to find the workspace ID now. So that's another environment variable I need. As you can see here, that is another one that I need. So for that, I have to go to my Prometheus one, the workspace that I created, which is Tampa Meetup, copy the workspace ID and paste it and run. So now I have my variables, environment variables ready. And all I have to do is run this Helm command. Helm, if you're not familiar with Kubernetes, Helm is basically a package manager that allows you to install applications on workloads on Kubernetes clusters. So here, what I'm doing is I'm installing the Prometheus. I'm fetching it from the Prometheus community repo. This is open source repo, just nothing to do with AWS or anything. This is just open source. If you're using Prometheus, it would work in AMP. Is the point that I'm trying to convey here. So I'm installing it into this namespace and using this YAML file. I'll show you what the YAML file is. But here it actually has some configuration about how the Prometheus Helm chart or the workload itself should be deployed. And there's something called service accounts. We don't want to get too deep into Kubernetes, but service accounts is a way for you to provide access to your resources in Kubernetes. So you can, in AWS, you can actually map the service account to IAM roles, which is called IRSA or IAM roles for service accounts. That is what I'm doing. Let's not get too deep. But I'm also running a sidecar container in this, which is an AWS SigV4 proxy sidecar. So the reason why I'm running here is, let me execute this first. So let us get this going. I'm going to run this get pods Prometheus. Let me do a watch, so we'll know what is happening. Right now, the container creating and so on, it will keep on updating. Okay, so what the sidecar is necessary because it's an open source Prometheus image, and it really doesn't know how to talk to the AMP workspace. AMP workspace is not everybody can send metrics to, right? They have to authenticate themselves, and it has to be in AWS authentication. So AWS IAM needs to be involved there. So what we do in this is we actually run the Prometheus server, which scrapes the metrics, and we make it to send the metrics to localhost because we are running this SigV4 proxy as a sidecar, right? So that is actually listening on port 8005 on the local host. So the SigV4 proxy is an AWS proxy. What it can do is it can actually forward any API, any calls that you're making to AWS from a non-authenticated application. You can proxy your request through that proxy. So the proxy knows how to talk to the AWS service because it knows that it needs to talk to this APS, to this endpoint, the APS workspaces.aws region and all that. So that is the mechanism we are using here. Okay, so it looks like everything is running. So let's quit this. If we go here, get pods Prometheus, you will see that we have everything up and running. So now what this means is we have a Prometheus server deployed. If we go back here, so we just did this, right? We did this and we deployed the IAM proxy, which is the SigV4 proxy, and we made this connection because through this is the one that is talking to this AMP workspace. Okay, so that is what we set up just now. So now I can be what I've done is I have I'm collecting metrics. It is using Kubernetes service discovery because we don't want to get too deep into that, but it's doing Kubernetes service discovery, discovering all the endpoints and collecting lots of Kubernetes specific metrics and sending them to my AMP workspace. Okay. In my initial demo, I also mentioned that, wow, this is so weird with the mouse. You can also use AWS distro for open telemetry to collect metrics. And this is what we did just now. So next, I'm going to show you how you can set up the ADOT collector or the AWS distro for open telemetry collector. So this is a open telemetry collector or the ADOT collector that can actually, you can create something called a pipeline that you can say what format you're receiving metrics in and what format you're sending the metrics out. So here we are receiving the metrics in Prometheus format, and we're going to send the metrics to an Amazon managed Prometheus service. So there is an exporter for that as well. So that is actually in this file in the workshop. If you go there, you can actually see that it actually clones all this. So this again, let me show you where this application itself is. If you go to GitHub, that's where the application is. I'll send that on this there, so you can take a look at it. Send it on Zoom. So if you go here under CDK, here under resources, let me change it to 1S. This is GitHub 1S. 1 second in Visual Studio Code. If you didn't know it, this is really a cool one. So here you can see that the file that I'm actually dealing with is this file. Okay, so this is the file that I'm dealing with. This is the ADOT collector configuration. So here you can see that it has, we're saying that the receiver is Prometheus format, and here's my Prometheus format, my script configuration for Prometheus, and here's my exporter format. So the exporter, I'm saying the remote write endpoint should be AMP remote write URL, which will basically be my remote write URL and the region, and there is. So I'm going to use the same file here. I have it here. So let me go here, and I have an older URL. I did this when I did the demo. So I'm going to just, well, the only thing that I need to do here is basically change the, sorry, it's all the way at the top. So here, so all I need to do is I need to change the workspace ID. So I'll go back to here, copy this, come back to my configuration. I pasted it. So now what I have is I have this URL, which is what I'm using to send the metrics to. Again, remember, this is another option. It is not mandatory. So we use the Prometheus server initially to collect metrics. And now I'm going to show you how you can set up using the AWS distro for Open Telemetry Collector. So if I go here, I find it, so I can see that this remote write is there. It is present. Okay, that is good. So I'm going to save that file. And what I'm going to do is I'm going to just do a kubectl apply, which will deploy my Kubernetes resource. So for that, I have to simply just copy this command, go here, I command V, and that's pretty much it. So if I go, probably have it already. Yep, in this, you can see that I have my ADOT collector installed just 7 seconds ago. Just it will be, or it should be up and running. Yeah, it's up and running now, and hopefully it's not crashing. But you get the idea. So it is up and running, and it's healthy. It seems to be healthy so far. So what it means is it's actually now sending metrics to my AMP workspace that I just created. Okay. All right. Let's go back to that. Okay, I did show the console already. Now let's get into Grafana. So what I'll do is I'll actually show Grafana, the managed Grafana service, and I'll show you how we can visualize the metrics that we sent from app. If you have any questions, like feel free to stop and ask. This should be a good time because we're switching to Grafana next. Okay, all right. So let's move on. Here. Grafana, if you're not familiar, it is a visualization tool. So it is open source, but there's also a hosted version of it, which is the Grafana Labs. It's by Grafana Labs. They also have open source version. Let's put it that way. We launched the service in partnership with Grafana. It is extremely popular in the visualization world. It is very popular in the visualization world. It can really, there's so many data sources that you can make Grafana to talk to. There may be 100 data sources you can talk to, and it can produce very visually appealing dashboards, and it's very fast. It renders. It's very efficient in terms of how it consumes and how it works, and it has lots of plugins. You can add features and so on, and it's very popular. Let's put it that way. It's very popular in the visualization world. Grafana is, and when we launched the Prometheus service, it was obvious for us to launch a managed Grafana service as well, because simply because they just go hand in hand. And like I said, like 99.9% of customers use Grafana along with Prometheus. So when you use managed service for Grafana, you really don't have to set up anything. You create a workspace just like what we did with Prometheus, and you suddenly get a highly available Grafana environment that is secure, that you don't even have to pay for to create, but obviously pay for usage. Basically, we charge per user license and so on. You can also, by default, you get the open source version, but you can also upgrade to Grafana Enterprise from within the console through AWS Marketplace. That means we will take care of the billing also. You can pay the bills, pay the bill for the enterprise license, so the Grafana Enterprise license, through the AWS bill itself. So it's well integrated within that ecosystem. So with that, yep.
I was just, it's Jeff, I was just going to say at Ashley Furniture, one of the things that we never had was a global dashboard. And all of our third parties, we'd monitor Salesforce independently, Microsoft Dynamics independently, our own apps, and we use Grafana just to merge all of those, plus the cloud. We happen to be Azure, not AWS, but same principle. Put everything on a dashboard, monitored all of our endpoints. It's definitely a slick tool.
Yeah, thank you for bringing that up. Yeah, it's actually a great tool. So the interface is super nice to look at, and also very customizable. That's lots of visualization options as well, which makes it super appealing. Which is important actually for you to kind of deal with lots of data and to understand, to make sense out of what's happening in your environment. Yeah, so there are so many data sources from AWS perspective. There are 7 of them, 6 of them to be specific. One is the alert destination, but these are not exclusive to the managed Grafana service. if you're using Grafana and managing Grafana yourself, you can still use these data sources, but it's just that it makes it, with managed Grafana, it makes it easy for you to discover data sources and use them. There's also many other plugins that are available. You can, if you used Amazon Managed Grafana, if you, for whatever reason, you run some workloads on Azure, you can use Azure Monitor data source to visualize metrics from and data from that environment as well. And same with Google Operations. There are many data sources that are available, including Datadog, New Relic, and many other stuff. Okay, so yeah, show me the console. Let's go there. Let's go to the Grafana console. Here, let me go here. So that's how it looks like. It is in private preview. This is not a public. This is not in public preview. It will go into public preview mode next month, in a month, basically. Okay.
Maya, if
And
we name drop your name, do we get signed up early?
you can actually submit. You can just go submit the form. These days we just approve it. We actually had lots of queries. We expected only about 500 customers to ask, but we crossed 500 in 2 days.
Wow. That's
Yeah. Yeah. Okay, let me create a workspace here. Tampa Meetup. All right, go next. There's the workspace. And AWS SSO is how you authenticate users into. You basically provision users in AWS SSO, and then that's how they get access to the Grafana workspace. You can choose either AWS managed or service managed IAM roles or customer managed IAM roles. I'm going to choose that. You can either make the Grafana workspace that you're creating to only reach into data sources from the same AWS account, or you can use this. You can use OUs. And what we would do is we would provision IAM roles using CloudFormation stack sets on those accounts that are under AWS OU or under the OU in that organization. So you can make the Grafana environment to reach into different data sources across accounts, across regions, and all that. So we'll do this current account for now. Select all the data sources. You can pick and choose what you want to choose. And here's a notification channel. Amazon SNS is one of the options that are available from AWS, or the only option from AWS perspective. But Grafana itself supports many other, and I'll show that as well. Actually, that's pretty much it. So if I click on create workspace, I'll have a workspace created, but I can't do that right now because I already have 2 workspaces. We are in preview, so restricted to just 2. Okay, so when you create it, you have here you basically have to assign users. You can add the users and assign users and all that. Now, the way you log in is through this URL. So you click on this link, it will take you to the Grafana login page. Well, it's supposed to show me the SSO page, but I think I had a session already, so it launched me inside. But that's my managed Grafana console, right? So then you will see this plugin right here that you can actually use to discover the AWS data sources. Here you can see that these are different data sources that you can connect to, one being CloudWatch, IoT SiteWise, and TimeStream and X-Ray and all that. So let's look at Prometheus because that is what we're interested in right now. And let's find the one that we created just now, right? Like I told you that we created it, and we also connected or sent the metrics to that AMP workspace. So it should be able to show that workspace that I created. Yeah, there you go, the Tampa Meetup. So it is showing up, and select that, add data source. And now I have it. Let me go to that settings, and maybe change that to Tampa Meetup. And you can see that it automatically discovered the query URL. So this is basically from here. So if you look at this, you can see that this is the query URL. So obviously it's ignoring the API vQuery, it's not needed. So you can see that it's automatically able to identify the URL for me. And it's using SIG-V4 authentication and uses SDK. The AWS SDK is, it's using that because Grafana has had an AWS Go SDK inside the Grafana environment itself. So you don't have to, kind of have an IAM role created, have, secret keys, access keys, and all that mess. You can just forget all that and just let Grafana do its job automatically. All right, so okay, data source is working perfect. Thankfully, let's go explore, right? So if I go explore and select Tampa Bay Meetup, and yeah, there are metrics. If I go and maybe just run a query, Yeah, there you go. Those are the metrics from my managed Prometheus environment. All right. What I can do is I can also, let me show you, we actually remember we use AWS Distro for OpenTelemetry to scrape metrics from this endpoint, right? So what I did is I actually have a, what do we call it? A dashboard created. So yeah, so there's a dashboard that I created to showcase some of the metrics. Let me go and change that. What I need to do is I need to change the data source to the one that we created. So we call that Tampa Meetup, I think. Okay, so that's what we called it. I'm going to copy that. I'm going to go back to Grafana. Here, Grafana allows you to import dashboards from JSON files, and I'm going to load that. It already exists. Okay, I'll call it X, import it, and there you go. So those are the metrics from my application that I just created, right? So yeah, so it's super straightforward. You know, it's pretty simple to use and all that. And there's also different data sources that you can use. Like I said, you can, all these different data sources that you can connect to, Jaeger, Zipkin, and all this MySQL, Postgres, and there are many data sources that you can connect to. These are all the approved plugins that are currently available. There are many more that Grafana supports, but in preview, these are the ones that we have. But when we go GA, you will see a lot more plugins that will be added to the list. So from AWS perspective, if I go, I can also reach into CloudWatch. So let's go to West 2, which is where I have my EKS cluster, which means I have a couple of nodes, right? So go to settings, dashboards, let me re-import it. And if I go to the EC2 dashboard, and there it is. So those are the metrics. So what Grafana did is it actually goes to CloudWatch in the sense it reaches out to CloudWatch using the get metric data API and gets all the data for you. Yeah, so that's the situation there. With that, what happens is, I remember I showed that very earlier slide, you had this part, but now you also have the other option added. So with that, you have customers have more options to choose from, and basically, it's really what your long-term vision is and how you want to build your observability in your organization in the long term, and you basically make a choice based on that. Right. So the capabilities are going to be merged in some ways. Like, for example, the AWS Distro for OpenTelemetry, it's going to be able to, the collector is going to be able to send the metrics to, it can actually already send the metrics to CloudWatch and Prometheus, for example. So the capabilities might overlap in some context, and also might be able to share here and there. But it really, for us, it's all about providing options for customers as to what they want to do. Okay, that's almost the end of my talk here. There's a question about CDK support, Barrett. So first, let's take one step at a time. There's not even CloudFormation support today, but that will be available when we go GA, and hopefully CDK also will be available at the same time. But I don't imagine customers using it so much, because how many times would you create a workspace, right? So you would create a workspace and you'd probably be creating more dashboards inside the workspace and editing dashboards. That's what customers would do. Maybe in an organization, you may have like 5 workspaces at best, right? Maybe dev, test, production, and so on, but you wouldn't have too many. But Grafana has dashboard APIs, which is what customers seem to use. They have CI/CD workflows that automatically deploy dashboards along with their application deployment. That is something that I see a lot of customers asking, and which is not available today either. That will be also obviously available when we go GA. And the GA timeline is roughly by end of Q2 is what we are aiming at.
So Imaya, do you think most customers are looking at this as, a better, more robust CloudWatch dashboard, or do you think just as many customers are excited about the third-party integrations and looking to find a home for a central dashboard across all of their environments, not just AWS?
Yes, I think that's a very critical point. I was about to say that, and you said that. So Grafana is super capable in terms of the visualization and all the customizations that come along with it. And at the same time, because of this various data sources and plugins that are available, it makes it super easy. Because I see a lot of customers using Datadog and New Relic, and then they have logs in Elasticsearch, and they have traces in X-Ray, for example. But the only way to use all these sources but still have a way to visualize is Grafana. And that's what customers pick when they are in that situation. But CloudWatch itself is a platform. So lots of customers are invested in CloudWatch. It's a big business for us. It's an entire platform. It has alerting solutions. It has dashboarding solution. It has all the AI specific features and many things built in. Who are customers who are invested in, they're happy with CloudWatch and they stay there.
Okay, makes sense.
Any other questions? I wish we had more participants, in other words, but still, I would have still done it even if you had only one person.
Quick question, Imaya. So one of my challenges in our environment is application teams hitting implemented API limits from an AWS perspective. Do you guys have a plan to enable visibility into API limit utilization, right? So we can see them prior to actual limit restrictions being enforced?
Yeah, there's a lot of work going on that space. CloudWatch already has those metrics. If you went to CloudWatch, you would actually see that metric automatically appearing. Let me see if I can actually quickly jump and show that to you while I'm here. Sure. Okay. Give me 1 second and I'll get to CloudWatch real quick. So if you're into CloudWatch, and I mean, let me say this, we can do better than this, but the point I'm trying to make is it is more and more services are publishing this. You see this usage metric, usage namespace, in other words. If you go here, you will actually see that these are the usage metrics that are being published. And there are many such services that are publishing those APIs.
So can you see something like describe security group or something like that?
I don't know at what level. These are like the service teams themselves, they publish the metrics. But if we look at the documentation, we should be able to find out all the metrics that are available. CloudWatch usage metrics. Give me 1 second. Yeah. If you go here, these are all the varieties of service code integration usage metrics. Yeah.
I didn't
These
think
are all the services that
architects used Google, Amaya. I'm shocked.
What's that?
I didn't think solution architects working for Amazon used Google for answers.
Do we have an option? Yeah, so these are the services that actually provide those that data. But this is service quota, I think, if you're looking at that, right? I think that is what your question was primarily. But yeah.
Yeah, service quotas aren't inclusive of all of the various API limits that are enforced. So we have some challenges occasionally where, security will be scanning security groups, for example, and they'll max out on the API calls in generating a, application outage, for example, right? I mean, visibility into that prior to the actual CloudTrail event showing up, because we've enabled that visibility, but having that proactive knowledge that we're at 90% or whatever would be very useful.
Got it. Do you mind like sending me an email with these details? Like I can certainly follow up. I can actually submit a product feature request if that doesn't.
Yeah, I mean, we're working through our account TAMs and stuff, right? But I was just wondering, because I saw this, presentation on observability and was wondering if you had any insight into, how that API limits visibility was going to be presented.
Yeah. Yeah, so like I said, it is available, but I don't believe it is available for all types of calls or all services. And as you can see, these are the ones that seem to support. But I think there's more and more services that are getting onboarded into this.
Okay, thanks. That's helpful.
Mhm. All right, stop sharing. Okay, any other questions? Did you feel like you got anything out of this session? Just would like to know if this was useful or too confusing or not that informative.
I'll say it did for me. You know, we work with a lot of customers who are always challenged about dashboards and third-party integration in addition to monitoring on AWS. Didn't realize, I mean, I knew of Grafana, the open source tool. We don't always recommend that companies that are lean on staff go down the open source route and implement that on a server, et cetera. But knowing it's, you know, going to be available as a managed service, I think that's very interesting to me. We also did a lot of care and feeding on our time series database, which, you know, if you're busy doing other work, just making sure you're managing the storage and watching the growth of the time series database, because the more excited you get about the telemetry, the more that database grows over time, right? And so it's great that it's available as a managed service. I didn't know it was available like that. So that was good.
Awesome, glad to know that.
Elliot, did you learn anything tonight, Elliot?
Yeah, a lot of it still goes over my head, but
Mine too.
we'll,
Trust me.
yeah, but from people that will benefit, like we share all the videos, so obviously, yeah, we'd hope more people came on here, but we've got 2,000 people in the group that will get the link, and we put it on YouTube, etc. So we send you all the links for that, and make sure people are taking all the information in, and I'm sure they'll understand it more than.
Yeah, that'll be great. I'm looking forward to the YouTube link, because that's one way to kind of, you know, get scale and get the word out.
Yeah, absolutely. No, we'll push that out over the start of next week.
Could you share the deck? Could you share the deck or a link to it if anyone wants?
Yeah, I can send a PDF version. Yeah, I can certainly do that. How do we do that? Like, do I?
You export it and send it to us if you like, and we can share it on our LinkedIn pages and push it out. That's tend to what we usually do.
Okay, I'll send it to Jeff on LinkedIn as PDF.
Okay.
Yeah, that's brilliant. Thank you.
Awesome.
Yeah, we charge for those, Maya. We'll just give you a small royalty.
That's a charge for everything.
Jeff does.
I know the number.
So he pays for his new AC and his new Wi-Fi.
When you get old like me, you're worried about retirement. You start looking for revenue any way you can.
No, yeah, we'll get it out to as many people as can benefit.
Thanks, guys. Thanks so much for turning up. I appreciate it. A bit of a smaller group, but yeah, hopefully the information was good and you enjoyed the talk. And Maya, you're a hero for doing that 2 days in a row. Thanks so much, mate. I'll make sure it all goes out to everyone and you can rewatch it or watch over his slideshow. As Jeff mentioned, we're doing one next week. That's, I think, midday. Is it midday? 12 o'clock?
It is.
Yeah, 12:30 it's on Azure Bastion. So
yeah, nice. So I know we don't talk about Azure in AWS, and that's just a thing. But yeah, if you're interested, have a look at our pages. Easily found.
I know Maya knows quite a bit about Azure. He's an equal opportunity.
You need to stop recording right now.
Thanks, guys. I appreciate it.
All right, everyone have a good night. Thanks,
thanks,
Maya.
thanks, Maya.
Guys.
Cheers, Jeff.
Take care.
Cheers, thank you.
Take care, everybody.